We're asked to evaluate this integral, but it's an absolute value. So we want to study what the actual function looks like before we evaluate an absolute value of it. So it's t squared minus 3t minus 4. We can set that equal to 0. It's quadratic, and we know it's going to make a U shape because a is positive 1. So to find out exactly where it crosses, we can factor, let's see, t minus 4 and t plus 1. So I factored it, and I set it equal to 0. So that gave me two places where it crosses. If I was to plug in 4, I'd get out 0. If I was to plug in negative 1, I'd also get out 0. So we know what the quadratic looks like now. It looks like this. But remember, we're taking an absolute value of it. So the integral changes between negative 1 and 4. Okay, we want to negate whatever the integral is going to give us, because if you were to take an integral without the absolute value, this would be negative area. But since it is an absolute value, we need to change it to be positive. So we're starting at negative 2. We want to integrate from negative 2 up until that changing point, up until negative 1 of this function, of this quadratic. And then we want to subtract the integral from negative 1 to 4, because that area is negative. And if we now subtract it, we're taking a negative and a negative to make positive, just like the absolute value tells us to do. So this is t squared minus 3t minus 4. And then we're back to addition because now we're positive again to finish out the limits of integration from 4 to 5. And I'm not going to write it down again. But that's t squared minus 3t minus 4. Okay, so the antiderivative is 1/3 t to the third minus 3/2 t squared minus 4t. And we evaluate that from negative 2 to negative 1. And then we're going to subtract this entire thing. So make sure to protect it in parentheses. Same antiderivative. Except it's from negative 1 to 4 for our limits of integration. And then we're back to addition of the same thing. It's 1/3 t to the third minus 3/2 t squared minus 4t from 4 to 5. Okay, so that's a lot of plugging in. I'll do some of it for you. We'll plug in negative 1 to this first one. Negative 1 to the third is negative 1. So this is negative 1/3 because it's negative 1 times 1/3. And then here, negative 1 squared is positive 1, so subtract the 3/2. And then this is going to be positive 4. And we need to subtract that by the lower part, by plugging in negative 2. So negative 2 to the third is negative 8, so this is negative 8/3. That's squared, so that's positive 4, so that's 3/2. Wait, no, sorry. That's 6. If you plug in negative 2 into this term, then if you plug in negative 2 over here, you're going to get out positive 8. So there's the first one. I did it right here. Okay. So I'm going to leave it here because at some point in the video, I guess I was going too fast. I messed up the fraction work. I mean, the rest of this is just tediously plugging those in just like I did in this first one. I just wanted to mention with this next one, make sure you plug in your limits of integration. Here, I'll do this one for you actually. Plug in 4t to the third, so that's 64 over 3 minus 6 minus 16, I think, because 4 times 3/2 is 6. 4 times negative 4 is negative 16. And then I'm subtracting it by what happens when I plug in negative 1. But I wanted to show you that this entire thing, this entire result needs to be subtracted. So you got to figure out what this next one is, compute that, and then distribute, and then put a negative sign on whatever you got over there. Because we determined at the beginning that this area was going to be negative, right? Okay, so unfortunately they don't allow decimal approximation, so you just got to tediously plug in all those numbers.